Hey there, and welcome to this explainer. Today, we're not just, memorizing dusty math formulas. We are literally unlocking the underlying code of both our physical and digital worlds. Think about the GPS you use every day, or the sweeping architecture of a modern skyscraper, or even the vast explorable terrains in your favorite video games. The crazy thing is, none of those exist without coordinate geometry. By mastering these concepts, you're essentially getting your hands on a master mapmaker's toolkit. We're going to learn how to precisely pinpoint locations, measure exact distances, draw perfect boundaries, and even map out curved spaces. So if you're ready to manipulate the grid and decode the very language of space itself, well, you are absolutely in the right place. Let's get into it.
Okay, let's dive right into our roadmap for today. We'll be navigating points and lines, looking at bisectors and boundaries, calculating polygon areas, checking out the equations of circles, going over some pro tips and traps, and then wrapping up with the final challenge.
Section 1. Navigating points and lines, defining your movement. All right, so before you can build a massive city or code a whole game environment, you've got to know how to move from point A to point B on a grid, right? These are your baseline tools. The most fundamental one? The distance formula. If you want to know exactly how far apart two coordinates are, this is what you use. The distance, or d, is just the square root of the difference between your x values squared plus the difference between your y values squared. Let's actually make this concrete. Imagine you're navigating between the point 2, 3 and the point 8, 11. First, you subtract the x's. 8 minus 2 gives you 6. Then, subtract the y's. 11 minus 3 is 8. Square them both, and you get 36 and 64. Add those together, and you hit exactly 100. Now, what's the square root of 100? 10. Exactly 10. Your final distance across that grid is 10 units. Honestly, it's so incredibly satisfying when the math just snaps together perfectly like that. You've just calculated the absolute shortest path between 2 points. Okay, next up in our navigation toolkit is finding the exact middle of that path. Enter the midpoint formula. Honestly, this one is just finding the average. You literally just average your x-coordinates and average your y-coordinates. That's the whole shebang. For instance, if you need to find the midpoint between 2, 4, and 8, 10, just add the x's. 2 plus 8 is 10, divided by 2 gives you 5. Add the y's. 4 plus 10 is 14, divide by 2, and you get 7. So your exact halfway point lands right on 5, 7. It's simple, it's elegant, and it is highly useful for splitting distances perfectly in half. Section 2. Bisectors and boundaries, drawing the line. Now that we can navigate and find the middle of a line, we've got to talk about creating perfect boundaries and exact intersections. This is where we go from just moving around to actively dividing up territory. Enter the perpendicular bisector. Now, what's really interesting about this is that this single line is a total multitasking powerhouse. It doesn't just do one thing, it actually accomplishes 3 specific tasks all at the exact same time. First, it passes precisely through that midpoint we literally just learned how to calculate. Second, it divides the original line segment into 2 perfectly equal parts. And third, it strikes right through that segment at an exact right angle. And I really need to emphasize this, that 90-degree intersection is absolutely everything. It is the defining, critical feature of a perpendicular bisector. If it doesn't meet at exactly 90 degrees, well, it's just a regular old bisector. That right angle gives your map its structural integrity. So, how do we actually build one of these in the real physical world? You just get into a rhythm. Step 1, draw your initial line segment. Step 2, take a compass and set its radius so it's clearly greater than half the length of that segment. Step 3, without changing that radius, draw arcs sweeping above and below the line from both endpoints. Step 4, find exactly where those arcs cross each other and draw a straight line joining those intersections. And step 5, you are done. The result is a perfect perpendicular bisector. You just turned an abstract geometric idea into a tangible, map-making reality. Pretty cool, right? Section 3. Calculating polygon areas, measuring the space. So we've mastered straight lines and boundaries. Now we actually need to measure 2-dimensional spaces. Like, how much territory does a shape actually cover on our grid? Now, there is a very specific formula for the area of a triangle using its 3 coordinates. It's a bit of a chunky calculation where you take 1/2 of the absolute value of a sequence, multiplying x and y coordinates together. But here is the ultimate mapmaker's hack. If you're faced with a really complex polygon, you don't always need to wrestle with a massive complicated formula. You can just hack it. Split the complex shape up into simpler, familiar shapes, like standard right-angle triangles, rectangles, or trapeziums. Calculate the area of those bite-sized pieces, add them all up, and boom, you've got the total area of your territory. It is such a practical workaround. Section 4. Equations of circles. Curving your perspective. Everything we've done so far has been all about rigid, straight lines. But hey, the world isn't just boxes and grids. We need to learn how to code curved spaces too. Just look at the elegance of these two formulas. When your circle is perfectly centered right at the origin, 0, 0, the formula is incredibly clean. X squared plus y squared equals your radius squared. So if your radius is 6, your equation is simply x squared plus y squared equals 36. Easy. But, and this brilliantly illustrates the math at work, watch what happens when we move the center away from the origin to just any generic coordinate. Let's call it a, b. The formula elegantly adapts. It becomes x minus a squared plus y minus b squared equals the radius squared. So let's say your new center is 3, negative 2, and your radius is 5. Plugging that in gives you x minus 3 squared plus y plus 2 squared equals 25. Notice how that negative 2 became a plus 2? Keep that in mind. Section 5. Pro tips and traps. The survival guide. All right, consider this your ultimate survival guide. You've got the tools, but using them under pressure, like during an exam or a crucial project build, is a completely different boss battle. I'm going to give you the insider playbook on exactly what to do, and more importantly, what not to do. Here are your absolute do this commands. First, subtract your coordinates carefully in the distance formula. Order really matters if you start losing track of your negative signs. Second, remember the midpoint is literally just averaging your x values and y values. Don't overcomplicate it. Third, lock this into your brain. Perpendicular bisectors always hit at exactly 90 degrees, no exceptions. Fourth, and this is a massive one, in the circle equation, the signs inside the brackets are opposite to the actual center coordinates. A positive 3 center coordinate becomes an x minus 3 in the bracket. Finally, always write down the appropriate units in your final answer. Okay, now for the traps. Do not fall for these. First, do not forget to square your negative numbers so they become positive. I'm telling you, that distance formula will completely fall apart if you leave a negative in there. Second, do not mix up the midpoint and distance formulas when you're under pressure. Remember, one is finding a length and the other is pinpointing a location. Third, do not use the wrong sign in the circle equation. Remember that opposite rule we just covered? Fourth, do not omit the absolute value when calculating triangle areas because, well, area literally cannot be negative. And lastly, watch out for simple arithmetic errors when averaging coordinates. Just double-check your basic addition and division. It's always the little things that get you. To help you dodge those traps, here is your ultimate cheat sheet. We've got the distance formula for measuring the gap, the midpoint for finding the center, the origin circle, and the offset circle. I highly recommend taking a mental screenshot of this visual blueprint right now and locking it firmly into your memory. This is the absolute core of your mapmaking toolkit. Section 6, the final challenge, testing your toolkit. So the crucial point is, having a toolkit is completely useless if you don't actually pick up the tools and use them, right? It is time to test your newfound mapmaking mastery. Here's your first quick practice challenge. I want you to mentally find the distance between the point 1, 2 and the point 7, 10. Think about the formula, subtract your x's, subtract your y's, square them, add them together, then take the square root. I'm not going to solve it for you right now. I really want you to actively recall those steps and prove to yourself that you know exactly how to navigate between those points. And for your final challenge to take away with you today, I want you to write out the exact equation of the circle that has a center at -2, +5, and a radius of 4. Be incredibly careful with this one. Think back to that survival guide and the trap about the opposite signs inside those brackets. If you can confidently write out that equation, you have well and truly decoded coordinate geometry. Keep practicing, keep building those maps, and I will see you in the next explainer.